So for this example, we're given an MRAP weighing 16 tons hanging from two support cables. We know that one of the cables has 8 kips of tension and is at a 20-degree angle, and we're asked to solve for the angle and tension in the second cable. So the first thing we have to recognize with this problem is we're given one of our forces in kips and one of our forces in tons. So your first step you always want to do is make sure that you have consistent units throughout. So I'm going to go ahead and convert this. 1 ton is 2 kips. Therefore, that downward force is 32 kips. So now that we have consistent units, we can look at the problem and see that again we have a 3-force statics problems, and we're asked to find the force in the second cable and the angle for the second cable. Okay, so again, statics problem, we're going to follow the same process. So our first thing we're going to do is we're going to look at our forces in the x direction, knowing that they sum to 0. All right, so if we were to look at, for example, our unknown force with unknown angle and try to break that into components, the first way we can do that, we can say that one side is going to be FR cosine theta and the other side is going to be FR sine theta. And we can go ahead and use that. We're going to come up with a couple equations that have both FR and theta as unknowns. However, that ends up where you have equations and you're trying to solve for thetas, which can sometimes get a little confusing in your calculator depending on how your calculator is trying to solve for that angle can bog it down. So there's a second way to look at these. You can know that this side of the triangle, FR cosine theta, is also just going to be the x component of FR. And likewise, the other side is going to be the y component of FR. All right, and you'll see how this works out when we get towards the end of the problem. All right, so if we go ahead and look, we're going to define to the right as our positive direction for x, up as our positive direction for y, and therefore our sum of the forces in the x direction is going to be FRx minus 8 kips times the cosine of 20 degrees. And if we go ahead and look at that, we have a single equation with a single unknown, so we can find that the x component of force R is going to be equal to 7.52 kips. Well, that's not really enough for us to find what FR and theta are, so we move on to our second equation. Sum of the forces in the y direction is equal to 0. So for this, we have the y component of FR in the upward direction. We have 8 kips times the sine of 20 degrees in the upward direction. And then we have negative 32 kips in the downward direction from the force of the MRAP. So if we go ahead and solve for those, we get that FRY is equal to 29.3 kips. So at this point, we're not done because remember, it asked us to solve for FR and theta, not the x and y components. However, what we can do is if we blow up that triangle, we want theta and we want FR. Well, we have that this side of the triangle is 7.52 kips, and this side of the triangle is 29.3 kips. Obviously, this is not drawn very well to scale, but that's fine. So if we have two sides of a triangle, we're able to find the hypotenuse using the Pythagorean theorem. So FR is going to be equal to the square root of 7.52 kips squared plus 29.3 kips squared, and that'll give us that FR is equal to looked at the wrong place on my solution. FR is going to be equal to 30.21 kips. And then we can use trigonometry. We know that the tangent of an angle is equal to the opposite side over the adjacent side. So tangent of theta is going to be equal to 29.3 kips over 7.52 kips. do the inverse tangent on our calculator, and we get theta is equal to 75.59 degrees. Now again, so we did that, I did that, going through and solving for FRY and FRX. You can also solve the problem, alternatively, by doing the sum of the forces in the x direction and is equal to 0, and breaking it up kind of the standard way, right? So you have FR cosine theta minus 8 kips cosine of 20. So that gives you a single equation with two unknowns. And then your second equation, sum of the forces in the y direction, is equal to FR sine theta plus 8 kips sine 20 degrees minus 32 kips. So again, you would have two equations with two unknowns, and you would be able to solve the problem. You would just have to do some substitutions where you find that FR is equal to 8 kips times the cosine of 20 degrees over cosine theta, and then plug that in for FR in your other equation, solve for theta, and then go back and solve for FR. And again, you'll get the same answer. It's just a second way of doing the problem. Both are completely valid. It just depends on which one clicks the best for you. So again, both options, both equally valid. You can use either form of the solution, whichever works best for you.